This is Professor X. We're going to take a look at how to do a character rig in Maya. So in this first part, we're going to cover joint placement and orientation, which will really be the foundation of the entire rig. So it's important to get this step right. I highly recommend that you watch this video back at 2 times speed because you can really get most of the information back at that pace, or slow it down if you need to. And I will also include timestamps in the video description. I highly recommend you skip around to just the parts you need because there's a lot of repetition. But hopefully you find something useful in this video, and let's get started.
Okay, so we're going to rig the BilliardBot character. This workflow is going to be fairly simplified. No rig is ever really done. You can add things forever, but luckily this character really isn't all that complex, so stopping short at some of these simple stages of it is going to do just fine for the types of animations we're actually going to need out of this character. So right now, obviously, I have a blank scene, and that's because I wanted to show setting up the project. Ideally, you would know this already, but just in case, because it is important once you start to get into this stage of a project where you're going to be tying together the rig, the models, the textures, all that kind of stuff. So we definitely want to have a project to organize all of that. So in Maya, you just come up to File, and we have Project Window and Set Project. Even though the name of it is not that intuitive, Project Window is what we can do to create a new one. So Project Window. And this will show current project default. If this is set to default, all of your stuff is going to go into that default Maya location, which is going to create a mess of files. And we want to set something more specific. So we'll do new. We can name the project to BilliardBot. And we will go to Browse. And I'm just going to place in here, I don't like using Maya's file browser, so I just copy this line from Windows Explorer, and we'll hit go. That should be in the correct spot now, BilliardBot, and now we've got all of these subfolders here, and this is what Maya uses for its projects, is this list of subfolders. We don't really need most of these, but it's going to create them for us anyway, even if they're empty. So that's going to be just fine. All of that is set up, and we can hit accept. Once we've done that, we should be able to see in our file browser that down here at the bottom, it has created a new folder, which was the name of the one that we just picked in Maya. And if we open that up, here's all of those subfolders and the workspace.mel. Never delete your workspace.mel because this is what tells Maya how to tie all of this stuff together. And then in here, if I open up scenes, this is blank because there's nothing in it. But since this model was already provided for me, I can just grab the latest version of the character, copy that Maya file into here, and now that's going to be part of the project. So then when I go back into Maya, if I go up to File, Open, we can see that it automatically went to this project location instead of looking in the default folder. A lot of people get frustrated with Maya's workflow of every time I go to open, it never goes back to where I was last. And I personally am frustrated by that too, but the solution is to build a project and it will always look in that project from that moment forward. So here is our Maya scene, Billiards character 45 merged. What an excellent name. I'm going to open this guy up. And I don't care about saving my blank scene. Continue, student version, yeah. All right, and here we go. This is the character as it was delivered from the modeling stage. Now, it's not necessarily 100% finished. It has been approved. There's no end guns on it or anything like that, but it doesn't have UVs either. So there's a little bit more modeling work to do, but lucky for us, the rigging process can start to be done out of sync with the modeling process because now the rigger, which is me, can start on joint placement and things like that, and the modeler can still go back and do UVs and all those kinds of things. When the UVs and everything are ready, I can just get that updated version and swap it out for this character, as long as the positions of the arms and joints and things like that are going to be exactly where they used to be. Okay, so what we want to do is grab this character and put him on a layer. So if we come down here to our bottom of our channel box, we've got these 4 buttons up here. With this selected, you can just click the one with a little circle on it, and this will actually create a new layer and add the current selection to that layer. And I'm just going to rename this layer to mesh. Save that, and then if we click on this little blank space a couple times, we can hit R to set it to reference, so we can't click on it anymore. Actually, that was a little premature. Let me undo that. There we go. So it's on a layer, and if I ever want to, I can hide it. Okay. So now, the first thing you're going to want to do is start your joint placement. Now, on a robotic kind of character like this, joint placement should be actually fairly easy if the modeling process was done in a clean way. We should have exact positions of vertices and joints and such. Now, we've merged this whole character together. Some people prefer to have it in separate chunks. I personally like it all as one mesh, and that's comes with the downside of losing our pivot points that we had on the model. Now, we could open up an old version of the model to try to find those pivot points, but I know where they were anyway. So I have a little script that I got from Autodesk's knowledge base, and I'll share that right here. Creating a locator at the average of a component selection. Wonderful. It's just this short little script right here. So if we just copy this, and I'll share this in the video description. If we copy this and we go down to our mel line at the bottom, we can just Control V and enter, and that will create a locator at that spot. So what's good about this is I can use that to snap joints and such too, and you'll see why this is useful in a minute. Now, to save that so I don't have to type in that script every time, we can open up the script editor right here, and we can find, actually I could just paste it right there. There it is, or we could have found it up here, but I'm just going to grab all of this line right here, and you can just drag this line right up into your shelf. And then when you're done dragging, it's going to ask, is this mel or Python? This one is mel. And now I've got a button that will let me create a joint at the center point of all of my currently selected components, which for me is basically a necessity for this workflow. Okay, so the other thing to make sure of is that locator looks huge next to our character, and that's because of the sizing of the character. Now, I already know that this sizing is appropriate because I set it up, but before you rig, you really want to export this thing into a game engine and see how it's actually going to look size-wise, because you really don't want to be scaling a character once it's inside of the game engine. That can cause all kinds of problems since your scripts will rely on things like parenting and other kinds of transforms that are going to be manipulated if that scale is not exactly 1. But I've already done that process, exported it, it looked good, it was the right size, so now we can actually start on our joint placement and actually building this rig. Okay, so I'm going to go up to my Create Joints tool, up to... Oh, we need to be in the rigging menu set, and then under skeleton, create joints. There it is at the top. And if we double click on that, we get the options for it right here. Now the create joints tool is kind of interesting. For me, I don't really use most of its functionality because I kind of come back through and override what a lot of that does for me. So I'm just going to reset the tool and pretty much call those settings good. So I'm going to collapse the tool settings. And let's just start placing some joints. I don't really care if they're exactly where they need to be because I'm going to fix that later. So I'm just going to come along here, click one for this kind of shoulder area. Make sure under my view, I'm going to change my view to, shading to X-ray joints. And we should be able to see that coming through. Okay, so we snapped to the grid over here, which is not what I was hoping for. I had forgotten that Maya likes to snap to the grid for creating these joints. Some people like to work from an orthographic mode first because that kind of guarantees that they're going to be on that flat plane. But as I said, I come back through and I override the positions of all the joints anyway. So what I'm going to do is turn on snapping for this character here, and I'm going to do, we could turn it into a live surface, but we also have this awesome option right here, snap to projected center. This is a really cool feature in Maya because what it'll do is with that turned on, we should be able to use our create joints tool, and when I click right about here, it's going to project where the center of that mesh is and actually place the joint in that appropriate spot, which is awesome. Okay, and so we've got one right there. and we'll put another one right about there. And again, I'm going to come back and make these perfect later. And we'll want the pivot point of the wrist to be probably right about there. We're kind of keeping it in line with this actual wrist little piece there. And then out from here, we can start to, I'm just going to come right out into the center here. And then from there, go out into the pivoting points of where these fingers are going to be. So right about in there, and then another one in there, and then just out to the tip. Okay, and I'm going to hit enter, and we should be able to go back to our tool and start again with another one right about there, one about there, and then out to the tip. Okay, enter, back to our tool again, click right here, right about here, enter. And we're only doing one side of this character because as with any symmetrical character, you can mirror the joints when we're done. Okay, and the interesting thing about the Create Joints tool is that it's trying to orient the joints as we go. And this is why some people have a particular workflow where they'll tell you, oh, never move the joints after they've been placed and that kind of thing. But again, my workflow has me repositioning them and recalculating those orientations, and I'll show you how to do that. Okay, then we actually do want one more for this inner piece here. So I'm going to go back to this piece here and just click once inside of there. Now that really didn't go where I wanted it to go. And for now, I want a better visual representation than that. So I'm just going to hit Q to get out of my Create Joints tool, W for move. And we're still snapping, but let's see if this does a better job positioning it now. We're still snapping to those the projected center. Okay, that's going to be good enough for now. Then we've got all of this stuff going on. Just for a better visual representation, we can just parent these right now. So I'm going to grab each of these, grab this one, and hit P. And that's going to connect up our fingers and make that visually make more sense. Same thing for this. Grab this one, grab that one, P, and we can see that a little bit better. Now, I'm also going to grab or increase the size of these. Now we could grab the joints themselves and increase this radius, but we can actually all at once go up to display, animation, joint size. And that's going to pop up this little box, and I'm just going to increase this a bit. There we go, so I can see a bit better. Okay, you don't really want it to overwhelm your view, but as long as you can see them. Okay, so now we need to do for the antenna. Now, again, some people would probably prefer to have this just be separate meshes, but I like my workflow where everything is attached to joints. Just for me personally, that's a cleaner situation to be in. So we're going to go back to the Create Joints tool. We're still on Snap to Projected Centers. And I'm going to click there. Then we'll go there, there, and there. Okay. Hit enter. And now we just need for the leg, back to the Create Joints tool. We'll come up, we'll put one kind of in the hip-ish area, and that really didn't work. So we're just going to pull this down. Okay, that's pretty close. Then back to the Create Joints tool, place one in the knee. And really, at this point, I don't really need the Create Joints tool anymore. If I were to come out of it and just hit Control D on this joint, it's really the same thing. We lose the benefit of it orienting them for us, but again, I'm just going to fix that myself later anyway. Okay, we'll come down to pivoting right there for the ankle. And on this rig, we had this weird thing going on with the feet, so I'm actually going to place a second helper joint down below, right about there. Let's see, I think that's going to work. And what that's going to let me do is flip this foot over so that when he balls up into a ball, the foot is going to be able to collapse. So you wouldn't normally have that joint right there. And then he doesn't have toes or anything. He doesn't flex his foot. So we'll just do one here, duplicate, and pull this one forward just to go to the tip of the foot. Now that's not going to be a binding joint, but it's just going to help me orient things. just like the tips of these fingers are not going to be binding joints. Okay, so that's just about everything. Now we do want to build this parented hierarchy, so I will grab this, P for parent, grab this, P for parent, again, P for parent, and again. There we go. Now, even though this character does not have the conventional set of hips and such, we would like to have a central joint that is kind of the root, the center of mass, the cog. And for me, that because he's a ball, I want that to align perfectly to his uh, the center of the ball itself, regardless of all the other extrusions that have come out of him. So uh, we can, well, first let's create that joint. Let's not get ahead of ourselves. We'll create the joint. Boop. And then I actually want to do another joint up here for his little visor piece in case I wanted to do anything interesting with that. So we'll add one more right over here as well. And again, our snapping has really thrown us off. So we can, at this point, turn off that snapping, just use our move tool, and get it approximately where we need it to be. So we'll place that right up about there. And for this one, we'll just get him kind of close to the center. Now for this one, just to better visualize it, I'm going to increase that radius like crazy so I know that it's the center one. And we'll probably do the same for this. Okay. Give these guys a little more radius as well. There we go. That's what I like to see. And actually these ones as well. Okay, so we just need to do one or two quick little adjustments. I realized that this isn't going to work for me with this positioned here because we actually don't want one for each side. We want one in the center that's going to control the visor all by itself. So even though it, in real life it might pivot from each of those points, for the sake of this rig, we just need this one to be in the center, and we'll get the exact positioning of that again as well. And then the other one was for the hand. Very similarly, I realized that as the hand collapses into this point here, we actually want to be pivoting from this kind of central point here. Now, if you want to move a joint that has children on it already, you can just hold D, which is the same as your moving pivot point. It works differently for joints. It'll actually move the joint, leaving behind all of the children. So I'm just going to move that to about there. And then we actually don't need this wrist to joint right here. So I'm going to grab this one, hit P, and that will actually make this a child of that one instead of a child of this one. Move this off to the side, and I'm just going to delete it. Now, it might look a little bit weird to have the bone protruding from the actual mesh itself right here, but that doesn't actually matter. It's just a visual representation of this connection. It's not actually having anything to do with which parts of the mesh are attached to it. Okay, so that should do it as far as our initial joint placement. Now we're going to see about cleaning up the exact positions and then connecting them together and doing those orients. Okay, so firstly, we want to get those joints placed correctly. And the best way to do that on a mesh that's got this kind of precision on it, this is a perfect circle here, it's going to have a perfect center point, is to use that locator script that I showed you earlier. So this is actually really simple to do. Let's go about this from simplest to hardest, I guess. Now you typically want to do this from the base joint all the way up, because if you move this base joint, all the ones along that way are going to move too, and that's going to be kind of counterintuitive. Sometimes you might have to unparent something before you do the move, if it's going to be a really tricky one, and then you just reparent them later. This is why we're getting this all out of the way right now. We don't want to do this halfway through the rigging process. Okay, so I'm going to grab this grab the mesh and then go into edge mode. And I've got, if we kind of look in here, we've got this kind of base point here, and this is going to be an excellent position. Now, wouldn't it be great if our joint was exactly where this manipulator was? Well, that's what the script is going to help us do. So with that selected, our manipulator automatically moves to the center point. If it isn't doing that, then you might want to open up your tool options for the move tool, reset the tool, and then it should move it right to there. With it positioned right there, we can then run our little locator script, which I've got my button right up here. And that will create a locator right at that center point of the selection. Now, I've noticed a problem in my current project here, which is that because we're exporting to Unity, I've adjusted the scaling units of this thing, and that has somewhat broken this script. But it's actually, all that's happened is it's 100 times too far away. So if we look up in the channel box, we can see the numbers that make up the position of that locator, and we can just click and drag to highlight them. When we let go, we can just type to override this. We can type times equals, so the little star, times equals 0.01, and that will multiply all three of these highlighted channels by 0.01, which will undo that 100 times too large effect, and it will place it right back down here. I wish I had a cleaner solution for that. If you're not working in a odd unit situation here, then that shouldn't have been a problem for you in the first place, but that's really not that terribly hard to deal with. Okay, so we got our first locator there, and I'm going to do the same thing on the next piece over. So we'll go into edge mode again. Oops, there we go. Edge mode, and we'll grab around here. And did we merge? Okay, we didn't merge those together, which is good because they're going to slide beyond each other. And we will, with that selected, we'll run our script again. Boom, we got the locator. Highlight all of those. Times equals 0.01. Boom, there it is, right there. One more time up here. Edge mode, grab all that. Looks good. Run our script. Grab all those channels. Times equals 0.01. Places it right there. And then for this one, this is not a binding joint. This is just a joint that's going to help us orient the joints. Sometimes you'll see these called leaf joints because you've got the tree of joints and then on the very tips you got the leaves. But this is kind of a null joint, a non-binding joint, but nevertheless it's necessary for orienting our joints down below. So similarly, we're going to go into edge mode, and for this one we could put it at the very tip, but because this is a ball, I like the idea of putting it right in the center on this one, so I'm going to double click there, run that script, grab all these, times equals 0.01, boom, and now we have our locators. So what we can do now is I'm going to hide the mesh. This is where our layers come in handy there. I'm just going to hit V. And on this, I'm going to start with the base, hold V, and just middle mouse drag it to right there. Grab the next one up, V, middle mouse drag, and just keep doing that. Oops, don't grab the locator, grab the joint. There we go, snapping each of these joints to each of those positions. And now we have this perfectly straightened up set of joints right there, and we don't need these locators anymore, so I will delete those, and we can unhide the mesh. Okay, and we'll see that those are very nicely placed now. They still have wacky orientations, but we'll deal with that next. Well, after everything else. So, the same kind of thing is going to happen for the leg here. Okay, so come into here. I'm just going to kind of come inside of my model here, grab this loop here, run my script, grab all of these, times equals 0.01, boom. Then we will go to the next piece down, which is the center of the knee. There it is. So this one is actually relatively easy to do. Now, because we've got a 12 polygon cap on here instead of a 16 or a number that would get us a point in the middle, we have a square right here instead of a singular point in the middle. So this is where this locator script really comes in handy. If there was an exact vertex to snap to, we probably wouldn't need this script. But we don't have that, so this script is going to help us. I'm going to select one on each side, which is going to put it perfectly centered right there. Run that script again. Grab all three channels. Times equals 0.01. Boom. That is our position. And we will come down here, do the same kind of thing. Face mode. And can we grab that one and that one run that script, times equals 0.01, boom. And then the one for the foot is a little less precise. From there, I'm just going to grab this locator, duplicate it, and I'm going to move it down using this little red plane here. I'm just going to move it down so that it's not sliding left or right. We'll just kind of get this positioning working very cleanly for us. Now, I might as well snap this one perfectly to the floor. It's not going to make that big of a difference in this case. A lot of the time when I'm working with feet, I like to have one joint snap perfectly to the floor. So I'm going to hold X to snap to the grid, pull down and snap right to there. So that's going to be the new position for that. And then duplicate this one, move it forward until it's at the tip of the foot right about there. And that's going to be just fine as well. Remember, that's not a binding joint, so it doesn't matter the real positioning of it. It's just going to help us orient the other joints. Okay, so that's it for the leg pieces. So let's get those joints snapped. We'll hide the mesh. And this can get a little hard to look at with these lines coming around in here, but we can figure out exactly where these need to be with our snapping. Hold V, snap to right there. Grab this one, hold V, snap to right there. And there's only, even though we've got all these lines crossing over us, there's only one locator that actually lands in that position. It's visually distracting, but it's actually not hard to get the snapping correct. Okay, and grab this one, and we will, I say that, and then I have a hard time telling what I'm looking at. There it is right there. So we'll grab this one, V snap it to there, that one, V snap it to there, that one, V snap it to there. Okay, so now we've got that really clean setup of those. We can delete all of these locators by, and then turn on our mesh again. And again, don't worry about the bone not necessarily aligning with the exact shape of the mesh. That's always going to be kind of non-representative of the real thing. The bone just shows the relationship between the joints. That's all it's really there for. Okay, then lastly, we need to do the arms. Well, I guess not lastly, we'll have those next, but let's do the arms. Come in here, edge mode, and then I've got this piece here because this character, normally you wouldn't need this kind of joint. It's kind of like a clavicle, so maybe, but what this one's really going to do for us is it's going to slide inside of the body here to let the arms really like fold up and collapse away for this guy's roll up animation. But that's why we're going to have this joint here. So double clicking that piece inside there, which is non-contiguous. This was modeled with this kind of stuff in mind. Right? So since it's non-contiguous there, we have this nice edge loop right there. Gonna double click that and run that script. Grab all these, times equals 0.01. Boom. Okay, now this next one is a little less precise. I'm going to do it based on these two faces here and here, because that seems appropriate to me as far as kind of a rotational point. There might be a slightly better one. Maybe we'll find out afterwards if that feels good to us or not. But I'm not going to be terribly precise on this particular go around. So with those there, we can then run that script. Grab these values. Times equals 0.01. And again, just to reiterate, if you were working on a character that was not scaled down like this, then this script might work fine for you from the get-go. But I think it's because we're working in the meters setup in Maya instead of in centimeters, and so it's kind of freaking out this script. But it's not so hard to fix that. Okay, this one again is another one with a very precise position, so we'll grab that. Okay, and that's going to get us to that center point exactly. Okay, I mean, you could technically grab this edge loop here, oops, this edge loop here and this edge loop here, and it would actually put that exactly in the same spot because of how cleanly this has been modeled. But obviously that's more clicks on things. But if I were to add this and this to the selection, it's also still right there in the center. As long as they are equally spaced across that kind of symmetry line there, then it's going to get us right in the center of them, and that's going to be just fine. Okay, and then place our locator, scale it down, times equals 0.01, boom. And then for the hand, this one is a little bit odd because, as I said, I realized that we're going to kind of pivot from the palm here, which is going to be a little bit interesting. So maybe when we go in here, you know what? Maybe we actually do want that because we want to be able to turn from the wrist and then afterwards we'll rotate from there. So despite what I said, making new decisions all the time, I'm just going to grab any old joint here, duplicate this guy, doesn't matter which, Shift P to get him out of there, and we'll just move him over to kind of that wrist position there. That way we can still pivot from the wrist if we wanted to. So look at me doubling back on my decisions. Okay, and we'll grab this one, P, this one to this one, P, and that fixes it. And now we need to find the correct position for this guy. So let's come in here. We might be able to get away with this one more time in edge mode. If we go into wireframe view, we can see in here, ooh, we got some extra polygons in there. We don't need you or you. Okay, and we'll just grab that edge loop right there. That's probably going to be just fine. And we'll run that script. And we will times equals 0.01. Boom. And then for this one, we're going to pivot around this point here. So I actually want this to come out like it's a cap, and that will pivot from that exact point right there. So what we can do is this one actually does have that exact point. So in this case, I actually don't need the locator because I can snap right to that mesh point right there. So then it's up to the fingers. I'm just going to, just so my screen isn't cluttered, I'm going to fix these joints so far. Let's hide the mesh, grab this one, and we could hold D to move this one by itself without affecting the others. Hold V to snap, right to there. Grab this one, hold D, hold V, middle mouse drag to snap. This one, DV, snap, boom, oh, too far. Oh, too far again. Where are we going? Come back. DV, snap, this one. DV, snap. There we go. That's what I like to see. This one, DV, snap. And then the palm, now I can get rid of these locators. Boop, bring this back, and now the palm can come into here. I'm going to turn on my wire on shaded, which makes it a little easier to look at here. Hold D, hold V, snap right to that point right there. And that's so that when we rotate, we can kind of pivot around that point there and close up into this hole nicely and just have a really easy time getting that where it needs to go. Okay, and then we can turn wire on shaded back off. We don't need that anymore. And we can figure this stuff out. Now, in terms of this angle here from the fingers up to here, that is not going to matter at all. These are the kind of metacarpals, essentially, of the hand, and we don't animate those, especially not on a rigid character like this. So it doesn't matter what those angles are. And then from here, I'm just going to keep doing that same trick. So we'll go into wireframe mode here. Grab this edge, grab that one. Oh, we got another interior face. We don't need you. Grab there. Run that script. And times equals 0.01. Grab this one. Wireframe. Got that internal face again. I'm just going to come through and delete each of these internal faces. Boom. And then get us back into edge mode. Grab that loop right there. Run that script. times equals 0.01. Boom. Math is hard. And then right over here, grab this edge loop. Run that script. You know what to do. You get the drill. Okay, so now we've got a locator for each of those. And again, before we get too visually hectic over here, I'm going to try to snap some of those. So hide the mesh and start snapping away. So grab this one and hold DV, snap to where it belongs. Ooh, focus in there a little bit. There we go. Grab this one, DV, snap, hold this one, DV, whoop, DV, snap, this one, DV, snap, boom. Those are all in their appropriate places. Delete all of that. Then we just need to do 2 more rounds of that. We're almost done. We're almost there. Then we go to the inside joint here. Now keep in mind, when we're picking this point of pivot, it's not like the center of the mesh chunk, it's where it's going to pivot from. So when you're doing this kind of thing, think about it, like look at your own fingers and where they bend and all that kind of stuff. So sometimes your actual joint placement might surprise you a little bit. Okay, and then go to right into here. We want that inside piece, and again we have these internal faces. We don't want those, so I'm just going to go through and try to clean those up wherever they don't belong. Oh, this one's got a couple, so we'll grab this. Let's see, can we just hide this chunk, go into solid view? There it is. What a mess. Yikes. We've got some other problems. Looks like we've even got like double faces going on in here. I don't recall this being an issue. Okay, so we will then delete that then. Oh, no, we need to... I'm going to hit Shift greater than and delete those. There we go. Then we'll just grab in edge mount this one to this one. Bridge. Boom. That will clean up some of that interior face nonsense. And back into face mode, Control Shift A. Control Alt H will bring that back. There it is. Interesting. I'm going to keep checking around for some of those problems. Again, this really wouldn't usually be the rigger's job, but this is a small enough issue that I'm going to try to fix it myself here, because the modeler might still be working on this part, and it would be silly for me to do too much work here. Oops. Too much work here just to have the modeler redo any of that kind of work. So we'll keep coming through in here, and we'll hide that. Yeah, again, interesting. I don't know at what point of the process this happened, but essentially it's been extruded once and left behind. So I'm just going to Shift greater than, delete, grab this edge, this one to this one, bridge, go back into face mode, grab each of these, delete them. We don't need those interior faces. That's much better. Grab all this, Control Alt H to bring that back. And it's good to bring it back early, because sometimes you delete something and you don't notice it, and you don't want to find that out after you do a whole bunch of work. So good to check. And then I'm going to hide that. Going to grab this one, delete that one. Oops, nope. Shift greater than, then delete it, then go into edge mode, then grab this one, then go here, then go to bridge, then go back into face mode, then grab these, then delete, then Control Shift A, then Control Alt H. Boom, we've got it stuff back. Now we can continue with the joint placement. Yay! Back into edge mode, come back down here, go into this view here, and now that we've got those interior faces removed, we can select that edge loop around, because they make up the non-manifold edge, which lets us select that edge loop. Okay, run our script to place that locator. Grab this, times equals 0.01. Boom. Back down to this one over here. Grab. You can tell I'm having fun now because I'm saying silly things. Okay, then come in here and run our script again. Times equals 0.01. Over here. Edge mode. Not that one. That one. Run that script. Times equals 0.01. Okay. Who said rigging couldn't be fun? There, we then go into shaded mode. And did we get one for the thumb? I think I missed the one for the thumb. I'm going to go back and do that. Maybe I did and I forgot. Well, I'm going to do it again anyway. So we'll come in here because it's so much fun. Then grab that loop right there, run that script, and times equals 0.01. Shaded mode. Boom. Okay, then we'll grab these joints, hide the mesh, move, DV, snap it, grab that one, DV, snap it, that one, DV, snap it, that one, DV, snap it. Okay, and now we're all snapped into those positions. Delete all of those. And this kind of snapping is not super necessary on an organic kind of mesh, but because this one is this rigid mechanical kind of shape, especially for things like these elbow joints, you really want to get those joints snapped perfectly to where they're going. Now on this, yeah, I think we'll have to do that one more time. So we'll just do it for the tips. We'll come back in here. There it is. Run that script. Grab this one. Run that script. Grab this one. Run that script. Grab this one. Run that script. And because I've got all four of these now, I should be able to, with all four of them selected, grab all three channels, and this should work. Times equals 0.01. Boom. Yay, it worked. All of them went right where they're supposed to go. Save a couple of steps right there. Hide the mesh. Grab the joint. And we don't have to hold D this time because it's got no children. And we'll just snap it to there. And then this one, snap it to there. Not the locator, the joint. There we go. Snap it to there. And grab this one, snap it to there. Okay. Excellent. Now we can get rid of those. Boom. There we go. Now the precise joint placement of those was not that important, but it is going to help with the orientation. It's going to keep that fairly clean because these are non-binding joints. Okay, so the last two are the one for the visor and the one for the center of the body. Now, again, this is, interestingly enough, this is not the first character I've ever done with a perfectly round body here that I wanted that clean center point on. And this is whether you did it with a UV sphere or a quad sphere, this one's a quad sphere, you should still have an edge loop somewhere that cleanly aligns with what we're looking for on here. Now on this one, we've actually got this perfect center point up there and a perfect center point back there. So I don't need my little locator script. I can just do regular kinds of snapping. So I'm going to go back into object mode. I'm going to turn on wire on shaded so I know what I'm looking at, which is, where'd it go? There it is. Boop. Grab this one. And we're going to kind of look from the back around there. Hold V, snap it to right there on all three axes, right back there. And we're centered up on the X, and we're centered up on the Y. Now we just need to do the Z, and so we'll hold V, just drag on Z, drag to right on that point right there. Remember, hover the mouse over the point you want to snap to, right there. And that will place that joint right in the center. And this is going to be great because if I want to roll this character, he will roll around perfectly from the center of this whole sphere shape. Another reason why clean modeling makes everything better. UVs, rigging, joint placement, everything just gets better if you've done a nice job on the model itself. Okay, and then for this one, Again, initially I was thinking I could put it around these kind of earmuff things, but because they're going to come in at kind of different angles, I only really need one joint for this. They're controlling this one shape together. In fact, I'm not even going to be rotating the earmuff things, just the visor in front. So we want to do one more time, edge mode, double click that edge loop around there, come back over to this side, shift double click this edge loop around here, boom, and that places our manipulator right in the center at the correct Z and Y positions for that. Run our script, grab all these, times equals 0.01, comes right into that position there. We can turn off our wire unshaded, hide our mesh, move this guy, V-snap him to there, and bring our mesh back, delete that joint, our locator, and there we go. We have basically perfectly positioned joints all throughout the mesh, just about ready to go do our next step, which is going to be orienting them, because the orients for these are all kinds of crazy and out of whack right now. But we got the position, which was the nice first step to that.
So before we orient these joints, let's get them named, because right now we have this long list of things that just say joint number 17, number 22, number 19, all that kind of stuff, and it's not particularly easy to decipher. So to expand this whole hierarchy, if you shift click on the plus, it'll open up the whole chain, which saves you a whole bunch of clicks. And now let's just kind of come through here and start naming these. I'm going to rename this, and you might have different naming schemes depending on which team and project you're on, but I'm going to use just the name that it ought to be, all lowercase, and then underscore L or R for left or right, and then I have nulls for the ends of joints. So I'll show you that right now. This one I'm going to call clavicle. So clavicle underscore L. This one here would be shoulder underscore L. This one would be elbow underscore L. This one would be wrist. And then this next one is a little bit tricky because it's outside of normal human anatomy. So I'm just going to call this one palm underscore L. It's not exactly where you would normally really put a joint like that, but I'll call it palm anyway. That should be just fine. This one I'm going to call thumb, if I can spell, thumb, and then underscore 01. Okay, and then this next one here, thumb underscore 02. And next one, this one is not a binding joint, so we're just going to call this thumb underscore null in all caps. Okay, and that's just going to help me identify which joint is not a binding joint. And we're going to follow that naming convention for the rest of these. So we're going to go index underscore 01. Oops, I forgot my underscore L's. So underscore L for each of those. I'm just going to come back and fix that for the ones up above. Underscore null underscore, let's see, thumb underscore L underscore null. Null is going to be that last piece on here. Okay. Okay, and underscore L for that as well. Boop, boop, boop. Okay, index 2 underscore L and index underscore L underscore null. Okay. And this one, this character's odd. He doesn't have all the normal fingers, but I'm just going to call this one middle because it's appropriate for that. So we'll go middle underscore 01 underscore L and then middle 2 and middle null. Okay, and then this last one, pinky underscore 01 underscore L. There we go. And 2 and underscore null. All right. You might put a 03 in there for the null, something like that, but I think that it's enough information as is right there. So then just make sure that you're comparing it to what your technical director wants. Okay, then this one, I'm going to call this one antenna. Antenna. It's like an ant with an enna. And we'll just call this 01. And there's no left and right side of this one, so we don't need any of that. And we'll just call this one 02, this one 03, and this one underscore null. Okay. And even though it's inside the mesh, it's not being used to bind. So yes, it's still a null. Okay. Then down here, hip, we will call this, actually, let's see. Some people like to name these things after the joint. Some like to name them after the mass of the body they are controlling. So you might call this upper leg, but I'm going to name them after the joints, since in Maya the workflow is based around joints instead of bones. If it was a bones kind of program, I would probably name it after the bones. Doesn't really make that big of a difference though. So this one's going to be hip underscore L, knee underscore L, ankle for this one underscore L, and this one is tricky. I'm going to call this foot pivot underscore L. And I'm using camel case here just because that doesn't really deserve its own underscore. It's one, it is one piece. It's not a sub part of foot. It's just foot pivot underscore L. And this last one, we will call this toe underscore null underscore L. Null. There we go. All right, and then the last ones are this guy here, and I'm just going to call this cog. No, you know what? I'm going to call that root. Root is usually, it depends on the software that you're exporting to. Root is sometimes the centermost piece of the character, and in some rigs they actually put the root down at 0 on the grid. That is going to depend on the game engine you're exporting to. I believe Unreal wants that bone down on the floor. But in this case, Unity will let us pick which bone is the root, and that's going to be this joint right in here. And then this guy is going to be visor. Okay, so the next piece is to start orienting these now that we've got them all named and we can actually tell what we're looking at here. So let's start with the easy ones. This guy right here is all out of whack, but you can't really tell, so we're going to grab all of these. We could right click here and say select hierarchy, and that'll select all of the children that belong to that one, but we've left behind all of these. So what I'm going to do is going to select all of it, and we're going to turn on the local rotation axes for these. And that's just going to help us visualize which orientation these things are in. So if we go up to display, transform display, local rotation axis. Okay, and that's going to pop these up. And we can see, especially on this antenna, it's probably the easiest example to tell, that the axes are all out of line with each other. They're all just kind of going all over the place. The rest of them are going to be somewhat similar to that. Because we placed them initially kind of close, there's sort of a relationship there, but we're probably going to have to override every one of them at least a little bit. And that's okay because it's actually not particularly hard to do, because Maya now includes the orient joint script. So we're going to go to make sure we're in our rigging menu set, and then up to skeleton, orient joint with options. Okay, we'll bring up the options, and we're going to take a look at some of these. First, I'm going to edit and reset settings just so we are starting fresh here. The orient joint to world, I don't think this is a particularly useful feature since we have more control with these options down here, so leave that unchecked. The primary axis, this is probably the most important one, because in these bone chains, what we really want is one axis to point exactly at the next joint over. And we can tell, if I grab this joint here, we can tell that's not happening because if we look over in the channel box for this joint, we actually have translates in the X and Y channel. And for some of these other ones, like let's see this shoulder here, we've got some translates in all three channels. And maybe for this wrist, all three channels again. A properly oriented skeleton has every joint that's part of a main tree. Every joint will just have a single translate, and the others will all be zeroed out because these transforms are relative to the parent. So by nature of it being a child of this one, it should be receiving this one's orientation plus whatever it takes in that particular axis. If it's having to add in multiple axes, that means the orientation is off. Is that the end of the world? Maybe not, but it certainly makes it a cleaner rig if we fix this. And it's not that hard to fix, so we're going to do that. Selecting this base piece here, they do need to be in this parent-child relationship for this to work. Then we come over to primary axis. This is the one that's going to point at the next joint. Now in Maya, you could choose Y or Z to make it match other software, but Maya really wants you to use X. It's mostly not a problem, but when you get into using spline IKs, the twist factor depends on it being X. It's possible that they've fixed that, but this has just been the mantra for so long, I don't dare try anything else because it works, and there's no real reason not to. So X aiming down the joint. This will aim this joint at its child and have that all taken care of. Then the secondary axis is the one that we want to point off in a particular direction. And this is kind of up to you. Well, really, it's up to your technical director so that your characters all match. The rotation that we want on this one, I'm going to say Z is our secondary axis. Despite the name, secondary axis is the one that we're probably going to rotate the most. It's going to be our first one that we edit in the channel box anytime we're editing that. So that's going to be your elbow bending or your knee bending or whatever the primary rotation of that particular joint is going to do. That belongs to this secondary axis. And I want Z because that's going to help avoid gimbal lock on the default rotation order. And then we don't have to mess with rotation order. So that's going to be nice. Z, and then let's aim it in a particular way that's going to be helpful for us. And I believe in this case, what we want is a negative X, which is going to point them off to this character's right side. So we'll change this to negative, and we'll change this to X. So it's taking this secondary axis that we've chosen, and it's aligning it to this third row right here. Okay, and orient children of selected joints, that will be just fine. And when we hit apply, we should see all of these straighten out and align with each other and behave. Boop. There we go. The top one got ignored because it does not have a child, and so it doesn't know how to align the way we wanted it to. But if we take a look over here, let's grab this bottom joint and look in the attribute editor. We can take a look down here at the joint orient, and we see that we have really clean values in here. We have -90, 0, and 90. So those are some pretty ideal numbers for a bone that's just floating there. That means because it's in these 90-degree increments that it's aligning nicely to the world. And if we look at the next one up, we should see, yeah, all zeros because it's actually matching that orientation flawlessly. Now, you're only going to get all zeros there in this kind of rare case where this bone chain is straight. You're probably going to get some other numbers in here. But what you will get is if we look over the channel box, now that these have oriented, we see that translate X is the only one with any translate at all. And if we were to drag this up and down, let's see. There we go, drag this up and down, you'd see that it's just pulling away from or getting closer to its parent. So 0 would put it right on top of its parent, and then the other one gets it farther away. I'm going to undo that because it was where I wanted it, but that's what's going on there. And this is a very human readable kind of number. It's like, this is the orientation, where's it pointing, and then how far away is it in that direction. So this is why it's really clean and nice to have these joints oriented correctly. So we're going to look at the next one, and we'll see that it also has all zeros here. Sometimes you'll get this rounding error where it's got a negative 0, but negative 0 and 0 are basically the same. That's just a floating point error. And that's going to be fine. And then the null joint here, this one didn't have children, so it's going to be a little bit weird. Let's go down to the attribute editor, and we've got the joint orient down here. I'm just going to type all zeros there, 0, 0, 0, and that's going to make it, even though it didn't have a child, that is going to make it match the rotations of its parent, because these numbers are relative to the parent, and if they're all zeros, it's going to match. Okay, so now that's all cleaned up. The next one is the leg. And this one's not going to be terribly hard to do. Let's grab this guy. Now, before we get started on this, anything that you're going to rig with IK, we really want to make sure that there's some kind of bend happening in it. And that bend needs to be more dramatic from front to back than it is from side to side. And I don't think that that's really what we've ended up with here. This bend is actually kind of happening fairly dramatically left to right, and not so dramatically front to back. So I'm actually going to move this joint before we do the orientation. You don't want to move it afterwards because that's going to ruin the orientation that you just did. So let's fix that now. Moving it, and just hold D. We did use that locator trick to position it, but I'm going to override that and get this kind of more important placement underway. I'm just going to move this back about there and move it over a little bit there so that it aligns better with that. What we're looking for is just a greater bend from front to back to follow this knee than we have from left to right, because that's going to screw up our IKs. Okay, that's probably good enough as is. It's a pretty subtle bend, but I think it's going to be just fine. Okay, although we could come back just a little. Oops, hold D first. We could come back just a little bit. Okay, I think that that's going to do just a fantastic job. So let's go ahead and orient these joints as well. We've got the local rotation axes on, and I forgot that this button exists right here, toggle local rotation axes or visibility. That is going to do exactly the same thing. They were nice enough to put it in this window since they figured you'd probably want to see that while you're working on it. So with this selected, same options. We want to be fairly consistent throughout the rig. Hit apply. And we see immediately the X aimed down to this bone, this X aimed down to this joint, and this one to this one, this one to this one. Although this one is, once again, left behind because it doesn't have a child of its own. Sad day. Okay, but all we have to do is make sure that this is going to work out for us here. Now, what I'm concerned with is what axes are going to be controlling this thing. Now, if we set this up correctly, the Z axis should be letting me, if I grab my rotate Z, I should be able to pull on that one front and back, and we should move front and back because, as I said, our secondary axis that we chose is going to be the one that we primarily are animating on. And for me personally, I like to have these be negative on the way backwards, and that's what's happening right now, and positive on the way forwards. And that's just because, in my mind, things that are getting smaller should be going in negative directions, and things that are opening up and becoming bigger should be going in positive directions. But that's really just a personal preference. Ask your technical art director what those choices ought to be. Then the translates here. I was talking about how great it was that the joints up here only have one translate. Well, that's not going to happen on the very first joint in the chain. And that's because it's not relative to its parent. It's one of many that come out from that chain. So if we look at this one, even on this chain that we just finished, this one's going to have 3. It's all of the subsequent ones that will just have a single transform. Okay. So back to the leg. That seemed just fine to me. Now, if you've made it this far, make sure, I forgot to mention, if you've been following along, this should not be the case, but if you're doing it on your own, be absolutely sure you do not have scales and rotations on these joints. These need to be zeroed out because this is their default. And what you're doing when you're animating this thing is editing these rotations. So you really can't afford for these to not be anything but 0. If they're not 0, then start over. Otherwise, what you can do, some people are afraid of doing it in this way, but if you freeze transformations on a joint, it actually works differently than it does on a mesh, and it should just take your rotation values and dump them into your local rotation values. That should be the case, but hopefully you just don't get into that situation in the first place. Okay, so next down here on the knee, let's grab the rotate Z, and as we go negative, we're starting to collapse that leg. That seems just fine. Good. And on the ankle, yep. And on the foot heel kind of thingy there. No, I had the wrong one selected. Rotate Z. There we go. Yep. And on this one, well, this doesn't rotate anything because it has no children. Okay, so that seems like it's going to work out pretty much perfectly for me. And what's really nice is that because this one was straight and then I just pulled this joint out there, is that we have this left to right angle just working perfectly. This foot is just going to rotate up and down like that. Super nice. If it was going off crazy off to one side, you might want to manually adjust that local rotation there. Okay, so then grabbing this one here, since it's at the end of the chain, we're going to go into the joint orient and just clear out all of these transforms. I only had 90 in that one channel, but now that they're all zeroed out, it matches the parent. This is really just nitpicking. It's not a binding joint, so it's never going to affect anything from that. Although with the foot, sometimes if you build your reverse foot roll based on these joints, that is going to make a difference. So, it never hurts to clean it up. That seems fine for now, so I'm going to grab the arm and do the same thing here. Once again, these settings should remain fairly consistent, and that's going to be just fine to start with, and hit apply. Okay, and we have begun to orient everything from there. Now, because we're working in an A pose here instead of a T pose, we do have a little bit of an issue with our orients as far as this goes. Now, whether or not you fully trust the Orient Joint tool to clean up your mess for you from the get-go, the one thing it really does nicely for you is it fixes that primary axis. Now we know that this bone or this joint is pointing perfectly at this joint, and this one to this one, this one to this one. So any manual work we do to clean this up from this point forward really is not that big of a deal. But trying to aim that one at that one perfectly manually, forget about it. It's just not going to happen, and this tool just does that for you. So it's a excellent starting point if nothing else. Okay, so from here, this one I don't particularly care that much about the way it rotates, but we do care about the shoulder. So if we grab in the channel box, we can grab rotate Z and see what our primary axis is doing. And we've ended up with kind of a front to back. That seems fine to me because that's going to put it in line with the elbow. Shoulders are weird because shoulders we actually use the primary and tertiary rotation axes. So we've got the rotate Y over here as well. And if I rotate that, that's going to be kind of my front to back motion. And you want to be careful with these because this is where you start to run into gimbal lock. Oh, look at that. No, sorry, I was wrong. It's not my front to back. It's my opening and closing. But we will rotate on X, and that will be some of my kind of front to back. So if I bring this one down, right to there maybe, and then we rotate Z, that's going to be kind of my front to back walking along there. So be careful with this. If you are running into gimbal lock, you might need to change the rotation order. Which can be done in the attribute editor here under rotate order right there. Under transform attributes, we have X, Y, Z by default. If you need to, you can swap that out for an alternative one. Usually what you want is your primary two axes to be on the left and right, and then the center one should be the one that you're using the least. But that's probably good enough for now for this character, for this rig. And what we want to take a look at now is what the next joint in the chain does. So if we grab this one, open up the channel box, rotate Z. Okay, we're starting to compress along there. And we are going positive on that one, so I could flip it around if I wanted to, so that it's closing up as that goes negative, but I don't feel that nitpicky. If I wanted to, I could change these settings so that it goes to positive instead of negative and then hit orient again. Or you can open up the local rotation axis and use the question mark to rotate those. But in my rigging workflow, I never touch the local rotation axes because to me it's kind of silly to have both a joint orient and a local rotation axis, and they are two different things. So I like to avoid that if I can. Okay, next up is the wrist. Now this one got a little bit weird because it's aiming down at that palm. So I almost think that we should orient it more straight. Yeah, a little more straight is going to be better on this one. And the reason is that the axis really isn't doing a lot of good jobs for us here. I would like it to be that one of these axes is more cleanly aligned with the wrist, and that both for the roll, so the X should be pointing more towards the inside of the palm here, and for the pitch and yaw of the joint there, so that he can kind of twist the wrist and wave and kind of go side to side. So this is where we get a little tricky, and this is where you're going to see why people prefer to use the local rotation axis method, because it's a little bit easier to use, but I believe this one gets a better result. Apparently that's just me though, but this is my tutorial. We're going to do it my way. So the trouble is that even with fancy things like preserve children and editing things in the attribute editor, Maya does not really have a clean way of supporting editing this one without editing all of its children. So I mentioned as a side note earlier that you might have to do some unparenting and reparenting. Well, that's what's going to happen here. So we're going to just grab this one here and hit Shift P so that it is unparented from the joint up above, and make sure that our rotation options, we're done with joint orient. I'm just going to close that. If we open up our options for tool settings, this is the one I was talking about, preserve children, but that will introduce rotation values. So it's like almost there, but not really. What we're going to look at instead, though, make sure that we are on axis orientation object, not world. That way, in real time, we can see a little bit better as we're orienting this thing. So we're just going to kind of look at it from this side view. And the cleanest one to rotate first would be X, because that will keep it aimed down the joint. In fact, later, I'm going to insist that you only rotate on X, but this palm one is, or this wrist one is a little bit odd in that regard. So we're just going to kind of finagle it into position. So right about here, I want Z to be my primary axis, and we can see that the Y pointing forward on that one. So I want Y pointing down and Z pointing off to the side. So I'm just going to rotate along X until that's about there. Oh, sorry, not rotate. Don't rotate. I just got finished saying that. No, don't rotate, but actually over here in the transform attributes down a little ways, we have joint orient. And so we have X, Y, Z, and we're just going to rotate on X. If we control click in this field, we can drag. This UI isn't very good. Unfortunately, we don't have the ability to do math or other things in here, but we do have the ability to kind of control drag, or we can just type in the exact values that we want. So I'm going to try a 95, because that'll be 90 degrees approximately plus from where we were. If you needed to, you can pull open a calculator and do that math outside of Maya. Other fields will let you do math, but not this one apparently, which is fun. So then from here, I would like it to aim up a bit, and since I've got this z-axis here, I should be able to just increase that z value, so x, y, z, and again hold control and you can click and drag in this. And that is not getting me exactly the result I was hoping for, but I think if I drag on y, there we go. So, you know, this workflow might not work for you. Usually you're only editing X by doing this, and it's not this big of a fiddling kind of process. But for this one case, because this particular character's palm alignment is bizarre, that's why it's an issue. Okay, that's probably good. I'm gonna try a little bit more, not that way, this way, a little bit more of that. Okay, I think I can live with that. That's going to leave us with the wrist Z as the primary axis to bend the wrist up and down, and that kind of is your primary thing that you do with your wrist, aside from roll, which is already predefined to being X. So I think we're in the clear for that one. And now, because we did it purely in these orient joints, the rotate axis, this is the local rotation axis right here, by the way, and the rotate channels, most importantly the rotate channels up here, stayed at 0. And I might have been wrong about that statement about freezing transformations dumping the numbers down below. So try to do it in a clean way like this, or use the local rotation axis if possible. But that's going to do just fine. Now we are going to lose the benefit that I had talked about where this one is pointing directly at this one. But that's okay, because we're a little less picky about this part of the chain. It's important for things like IKs, which we would do like up on this upper part of the arm here, but we're not doing that for the palms, so it's not going to be a big deal. So next, I'm going to reparent this. So grab this piece, and P. And because we moved the thing while it was unparented, now it shouldn't be a problem anymore. And if I grab the wrist joint now and I try out some of those rotations, let's go to the channel box, grab rotate Z. I should get that kind of waving effect, and that's working out for me just fine. Yeah. And if I grab the rotate X, we should roll. Okay, and if I grab rotate Y, we should kind of go side to side. Good, and that's really what you want out of these kinds of things, is that each of these axes does a specific kind of task. Now, if you get too many of these things working all together, that's when you're going to get into gimbal lock, which is why shoulders are always such a pain. But moving on, we have some fingers to do. Now, this character's fingers are a bit unconventional, so we'll see if my methods hold up on this, but we are going to have a look and see. So again, our orient joint tool, it kind of failed us in this regard because the character's in this A pose, and so the axes of these are kind of poking upwards instead of appropriately off to the side or anything like that. So the one thing that the Orient Script tool did for us, though, was that it got that primary axis aligned. So the x-axis is pointing right at this one, which is exactly where we want to be. So what I'm going to do is we're going to pick the nicest orientation for this one, and then we'll worry about the other two in a minute. So just like we did before with the palm, I'm going to unparent this one, so Shift P, leaving this one with no children. And now when I do my edits to it, it's not going to throw everything off. Now this time, we're only going to rotate on X because we want to preserve that the X axis perfectly aiming at this. And if we start to rotate the other two, it's going to get misaligned. So just rotate this one. And we could just type some numbers, or we can hold Control and drag left and right. There we go. I've got a really wide monitor, so I can drag pretty far. Okay, and what we're checking for is just to get that alignment so that as the fingers curl up, the z-axis is kind of aligned with that finger curl. Now this one is a little bit odd. Normally a humanoid organic finger would be a little bit more decisive of how it was going to bend, but I'm having to do my best at interpreting how this finger was supposed to open and close, and I say it goes this way. So unless the modeler comes back at me and tells me otherwise, then that is going to be how the finger moves. Okay, and so that feels pretty good to me. So I'm going to do that for each of these fingers. Okay, so grab each of these and Shift P. And grab this guy, and again, only the X for joint orient. Okay, and I'm getting that Z-axis aligned to be as horizontal through this mesh as possible. Okay, and that feels pretty accurate. Okay. If you are super picky, you might even type exact numbers in here. But there is a certain point where you're going to be spending more time trying to calculate the exact numbers, and the benefit of it is going to be unnoticeable. At the end of the day, floating point imprecision is going to kick in, and the most perfect math in the world is still not going to result in the exact number that you were hoping for. So try not to waste too much of your life doing this. But we're just going to get this to a clean result that's enough that really will make a difference, and then we'll kind of call it quits there. Okay. Yeah, that feels pretty good. We've got Y pointing upwards for each of these. Okay, and what that means is that we can roll on Y to kind of spread the fingers apart from each other, and we can roll on Z to curl the hand up into a fist. So the next thing to do is reparent each of these. Oop, let me get my camera angle there. And it's a little tedious. Again, if you do the local rotation axis workflow, then you don't have to do the unparenting and parenting thing. So that's personal preference, really. Okay, so now that those are aligned like that, what I like to do from here is, well, first we should actually check if these are doing the thing we're expecting them to. So let's grab each of these And the cool thing is, because their axes are aligned, we should be able to, with them all selected, go to the rotate Z. And if I curl this in and out, we should see it start to make kind of a fist. Yep. Closing the hand, spreading the hand, kind of hyperextending backwards. Yep. And rotate Y should be kind of spreading the fingers left and right. Awesome. So that consistency is part of what's so important about orienting these joints. If your animator comes in here and wants to curl your fingers and each finger's going a different direction, then they're going to have a nightmare of a time trying to animate the character. Okay, so one more time, we're going to unparent, this time the nulls from the tips, and Shift P, and we will come into each of these. Now this time, rather than trying to rotate it around by hand, I'm just going to clear out everything except for the X and see if that helps. So 0 and 0, and that got me not where I was expecting. Let's undo that. Okay, well, let's see if we undo X. There we go. Sorry, I had it backwards. Only undo X, right? Because we don't want to change those because that's going to change the orient. Now, if we set just the X1 to 0, that is going to clear this out and kind of keep it in line with the parent. So the Y's are pointing in kind of the same direction and the Z's are kind of pointing in the same direction while still preserving the X pointing at the null. And that's good. Okay, and then we can reparent this guy to this guy. And the null, we don't care about the orient. And just, again, just to be clean, I'm going to clear out all three of those. Boom, boom, boom. Okay, so grabbing this one, clearing out the orient X, this one, orient X to 0, this one, orient X to 0, boom, boom, boom. And we can start to see that they're actually like aligning pretty much perfectly with the parent joint there. Again, while still pointing at their nulls. So we'll grab this, parent, oop, parent, parent. Okay, and then we'll come through each of these, and 0, tab 0, tab 0, 0, tab 0, tab 0. Sounds like a diet soda. 0, tab 0, tab 0. And there we go. Okay, so, oh, and then the palm, I guess. So for the palm, palms are tricky because, as I mentioned before, when we were talking about really nice orientations, how the only the base joint should have those multiple transform values. Now this one is weird because we aimed this one away, so it's going to have multiple translate values here, and also each of these fingers is going to have multiple translates because this joint chain doesn't go in a single direction. It can't orient to all four of them at once. So our best case is that only one finger is oriented nicely. But I don't really care if any of them is in line with the palm because we don't animate these metacarpals, as I've said before. So I'm just going to unparent these, and I'm actually going to fix the palm so that it is most optimized for doing the kind of collapsing hidey hole animation up here. And this is really unique to this rig, so make of this what you will. So we'll just go into this guy, and first I'll try just starting by clearing out these rotations so that it matches the parent, and that's honestly probably going to be enough right there. I might on Z increase that so it just aims a little bit more to be flattened with the palm, but really that's going to do it for me. Nice and flat, as long as we have an axis aligning with this so that we really do have control over what's going on this piece. And then we'll go to each of these, grab this last one, reparent it, boom, nice and clean. We've done that for each of these pieces, although really I'm starting to be bothered by this joint in here. It's not going to matter because I'm not doing that kind of animation, but here I am going overboard, so we might as well fix it while we're at it. I'm going to unparent the shoulder, and I'm just going to grab this one and grab that joint orient. Remember, only edit the X. I'm going to try with a 0, and honestly, that's probably fine. A Y up. I'll try 90 degrees on X, or sorry, a negative 90 in this case, and that's just because we've got Y's pointing back that way on some of these joints, and at least there's that kind of consistency. It's not going to matter that much in the end. Okay, and then we'll parent that again, and we have that joint back in place, nice and clean. And then it's up to these ones. So this joint here, interestingly, doesn't have any children. So where do we orient that one? That is an excellent question. What I would do, well, if it did have a full spine, you would orient the X to aim up the spine. But in this case, I think it might actually be cleanest if I just orient this one to the world. So if we just did X to aim along X, Z to aim along Z, and Y to aim along Y, which is actually exactly how it is right now. You can see the joint orient is 0, 0, 0. Because it's not a child of another joint, that means it's a child of the world. So these numbers are relative to the world. And with them zeroed out, it aligns perfectly to the world, and that's going to be just fine for the root. For the visor, that one, I feel like this is in the same situation, really. Although, no, because for consistency's sake, we want Z to be the primary thing that we're rotating on this. So we want to have X aimed, in this case, well, we'll do X straight up. And so we'll just do, we could run our orient tool again. In fact, I'm just going to do that. So I'm just going to grab this one, skeleton, orient joint, and we will take a look at this. It doesn't have a child. That's the problem. So I'm just going to duplicate this, move it straight up, make it that a child of that. And this is the crazy stupid workaround for this. It's probably doing more work than actually rotating it would have done, but there we go. Okay, so now it matches our antenna at least. um, you know, different workflows to do different things. You're learning a lot in this video, maybe, I don't know. But there we go. So now we have each of these joints oriented nicely, put in place, and now we can actually hook them up as children. We didn't want them all children of the root before because the orientation of the joint chains would have been screwed up for that orient tool. But now we're not worried about that anymore. So you want all of your joints to eventually be children of the root so that when you move the root, everything goes along with it. And you're going to get these weird bones, like a bone from this piece to this piece. Again, pay no attention to the bone itself. We don't care about the way the bone looks. It's the joint placement that matters. So we'll grab this one and this one, hit P, this one to this one, hit P, each of these and hit P. There we go. And everything should be flowing outwards from here, down the joint chain. Nothing should be flowing back into the root. Okay, so this is just about ready to mirror. It's a good idea to kind of come through here under your channel box and just look through these. In the cleanest setups, you wouldn't have any rotations on any of the joints, no scales on any of the joints, and then transforms, you'll have 2 or 3 on just the ones that are randomly placed off like this from the root, and then inward from there, they should each only have an X. So X, X, X. Okay, that's nice and clean. This one's bothering me. Even though I said it's basically the same, I'm just going to override it by typing 0 anyway. It really is the same under the hood. It's probably some crazy far off distance floating point number, but I decided to be picky today. Okay, and then we'll grab this one. And again, it's one of those crazy ones off from the root, so 3 transforms. Then this one should be just 1 transform, just 1 transform, just 1 transform. Now, because we've edited the palm, this one's going to have 3 probably. Sort of. It's got a -0. There we go. Then we've got these ones. And again, because they're branching outwards, they're going to have multiple transforms each. Yep, but still no rotations and no scales. You should never have rotations and scales. And then these ones should just have back to 1 again. Just 1 on X, just 1 on X, just 1 on X. Okay, same thing for the hip, all 3, but then when we get down to the knee, just 1, just 1, just 1, and just 1. Okay, so this is a very clean setup for joint placement. It might have taken longer than most people would have put the effort into. On a robotic kind of character, that extra time in the joint placement really will pay off because of things on like on the knee here where we have it was modeled with a perfect center. The audience is going to expect it to rotate from that perfect center. And if you don't spend enough time cleanly placing that joint, then it's going to be obvious that you're doing a sloppy job. So the very last thing on here is to mirror these joint chains. So I'm just going to select this piece here, and it'll mirror all of the children. So then we'll go over to skeleton, mirror joints with options. For the mirror across, I don't know why they just didn't tell you one axis, but instead you're creating a plane that you're going to mirror across. So this is YZ. So basically we're excluding X, which is our left to right. So it's actually going to mirror on X. This is probably the most complicated way they could have listed it, but that's the one we want. And then mirror function. We have orientation and behavior. Almost every time you're doing a character, you want behavior. And this is, as I was describing before, when you curl up the fingers on a rig or you open the palms back up, you want those negatives to match the negatives on the other side and the positives to match the positives. If you do orientation, you're going to get that backwards from one side to the other. So keep it on behavior. And then over here, this naming convention, we've got search for underscore L and underscore R. I'm going to switch these out for my lowercase versions because that's what I used in this case. And we should, if I open up my rig over here, we've got these chains. If I hit apply, we have a complaint. Too many arguments. I'm not sure why it was complaining about doing 2 at a time, but we'll just do 1 at a time. There we go. Okay, and it even made the child set up there. Now, because we fixed all those orientations before we did the mirroring, the orientations came over properly as well. Now, don't worry about these looking backwards from this hand. That's exactly what I was talking about, using behavior instead of using orientation. And the true test is, if we open this up, I'm going to grab all of my fingers on each side. Okay, not the palms or anything like that, but we've got all these fingers, and we're going to grab the rotate Z, and if we scrub inwards, so negative, we're starting to make a fist on that side and a fist on that side. If this hand is opening up and that one's closing, that probably means you did the mirroring incorrectly, and that's going to be a pain in the butt for the animator. So this is exactly what we want, even though visually it might be a little bit peculiar to you. Okay, so we've got that orientation and the positioning of our joints done. So now we're pretty much done with the joints. The last thing to do would be to turn off all these local rotation axes. So I'm going to grab the root, and this time everything is a child of it, so we can hold right click, select hierarchy, and it's going to grab all of those, and we can just turn off our local rotation axis visibility. Boom, nice and clean. That's what we're talking about. We should make a layer for these now. So select hierarchy. Again, this button over here with the circle on it will make a new layer and add the current selection to that layer. And then we can rename this to joints layer, and make sure that you don't use any spaces. Maya will complain in here, and make sure you're not naming this the same name as something that's already in the hierarchy over here, because Maya's dumb and it doesn't know the difference between a name in the outliner and a name in the layer editor over here. But that's going to be just fine. We'll hit save, and we can turn off and on that visibility. We've got the same thing for our mesh. This thing is pretty much at completion of the jointing phase. Some people call it quits here, and they're like, yeah, I made a rig. No, 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 no. This is just the jointing phase, and it's just the beginning. But hopefully you learned some stuff, and the next video is going to be about setting up the controls.